The best way to predict what's going to show up on your next SAT is to look at what showed up on the last one. Let's go over the 10 hardest questions from last week's SAT. If A, B, and C are positive constants, such that 53% of A equals 27% of B, and A equals 34% of C, then what percent of B is equal to C? Round your answer to the nearest tenth. Exclude the percent sign from your answer. Okay. This is a question that should be exclusively done on Desmos. So let's type in this first equation. Okay, perfect. So we just typed in 53% of A equals 27% of B. And we literally typed in percent. By the way, whenever you type in percent, it automatically does the of, if you were wondering. A equals 34% of C. This is the second equation. And then the third equation is a little tricky, so let's walk through this together. What is B percent of C? How do you make that into an equation? Anytime you see what in a percent question, replace that with a variable like n. I always use n. So let's read this one more time. N% of B is equal to C. Isn't this a lot easier to just make an equation? N% of B is equal to C. All right, we don't want to add any sliders. We want Desmos to calculate the value of n for us, because since it's asking for what percent of B is equal to C, we want to find out what n is. Here's how Desmos is going to calculate that for us. The first thing that we are going to do is on Desmos, there should be an A equals, a B equals, and a C equals. Why? Because Desmos only likes when variables are defined like this, when they're on the left-hand side of the equal sign, and they're defined only once. So what do we need to do here? Well, there's already an A equals here. It doesn't matter what order they're in. It could be like B equals first, then A, then C. But let's swap this C to the other side. So right now we have A equals and a C equals. All we need is a B equals, since we have three variables, A, B, and C. So how do we turn this first equation up top, this one, into just a B equals something? Well, let's first write it out. Anytime you see of, you can just replace it with a multiplication. It's the same exact thing. Okay, and I think you can see it now. You just isolate for the variable B by dividing the 27% to the other side. Okay. So let's delete all of this. Let's divide it by 27%. And when we do that, we're going to run into a little bit of an issue because this says percent of. So instead of that, just write 20% as a 27% as a fraction. Anytime you see percent, it's the number over 100. 2% is 2 over 100. N% is n over 100. 0.5% is 0.5 over 100. Just remember that, number over 100. And then this is B equals. The last step is just to switch this equal sign into a tilde. Oh. There we go. See how it calculates for n for you? You want it to the nearest tenth, 149.8. This is your answer. Desmos did all of this for us. all we really needed to do is make it in terms of A equals, B equals, and C equals. That's it. By the way, if you're not sure which equation to put the tilde on, it's always the equation that has the variable that you want to solve for. So since we wanted to solve for n, because that was the what percent, we replaced this equal sign here with the tilde. Okay, perfect. Let's move on. The table gives the volume of two similar cylinders. If the radius of cylinder A is 9 centimeters, what is the value of S minus T? And then this is the surface area. By the way, if you guys are new, my name is Risav Roy. I actually take the SAT with my students. So anyone can take the SAT. It's not just limited to high schoolers. So I'm an SAT math tutor. I take it with my students so I know what's on the test. And this question was actually on my version of the test. It was also on many students' versions. So they texted me and they were like, I saw this cylinder question. The funny thing is that my students know that this was in one of my videos, like word for word. I predicted this in one of my videos. So, okay. S minus t. Let's figure out how to solve this. In order to solve S minus t, we need S and we need t. And those are the surface areas of cylinder A and B. Okay. The first thing that we want to do to find the surface area, let's find the surface area of cylinder A first. That seems simpler, right? So, you know what? Surface area of cylinder A is going to equal 2 pi r squared plus 2 pi rh. Now, the surface area of cylinder A is represented by T pi. And the radius for cylinder A is actually 9 centimeters. It's given. So all we need to find T pi is actually just the height. How do we find the height? We can take this volume right here, 1296 pi, and actually set it equal to the volume formula for any cylinder, which is pi r squared h. And since we know the radius is 9, it's really just 9 squared h. So 1296 pi and then instead of h, I'm going to write x. So Desmos actually graphs it. H is equal to 16. Perfect. So we just found the height. We can erase this. Let's put this up here. H is equal to 16. So we can replace this with 16. And before we put all of this into the calculator, why don't we just divide everything by pi? So all of the pi's just cancel out. That just makes it a little easier for us. Okay, perfect. So we just calculated that t is equal to 450. Not t pi, we calculated t because we divided the pi out. Let's write this here. We are very close to getting our answer. The only problem is this is the hard part of this question. This is the hardest part. What we need to understand to solve this last part of this question is something known as scale factor. This is probably one of the most complex concepts on the SAT. So here's how I'm going to explain it. Let's say we have two cubes cube A and cube B. And the edge length on cube A is 2. The edge length on cube B is 6. That means that the scale factor is 3. Why? Because every edge, or let's say this edge and this proportional edge, is 3 times as big. Scale factors only work when the two 3D shapes are similar. So since these, let's assume that these cubes are similar. I mean, all cubes are similar, but my point is if two 3D shapes are similar, there's always a scale factor. And in this case, you just take the edge of B divided by the edge of A, and that is equal to 6 divided by 2, just 3. This is our scale factor. The reason why it's important, let's put this down here, is because the ratio between the surface areas of B divided by A is actually equal to the scale factor squared, always. And the ratio between the volumes of B and A is always the scale factor cubed. So in this case, this is going to be equal to 27, this is going to equal 9. You don't need to know why this works. You just need to know that it works. This always works for two similar 3D shapes. That the ratio between the volumes is the scale factor cubed. The ratio between the surface areas is the scale factor squared. And the ratio between two proportional sides is the definition of the scale factor. Let's figure out the scale factor between these two cylinders. Well, I just told you that the ratio between the volume of one 3D shape and the volume of another 3D shape is the scale factor cubed. So what is 279,936 pi divided by 1296 pi? 216. So if we want to find the scale factor, we just take the cube root of 216. Just go to functions, scroll all the way down. So now we know that the scale factor is equal to 3. I mean, not 3, 6, because it says it right here. That means that the edges on cylinder B is going to be 6 times the edge on cylinder A. Meaning the height on cylinder B is 6 times as big as the height on cylinder A, and the radius on cylinder B is going to be 6 times as big as the radius on cylinder A. What we can do is we can actually shortcut that entire process. We don't need to find the radius. We don't need to find the height. We can simply find the surface area because we know the ratio between the surface areas. It's the scale factor squared. So surface area of B divided by the surface area of A is always the scale factor squared, which is 6 squared. So all of this is equal to 36 because that's 6 squared. Now, the surface area of B is S pi. And this is T pi because it says it right here. Now T is equal to 450. So we can actually calculate what S pi is by multiplying 450 to the other side. Do you see how we did that? We just used the scale factor, equation, and we just substituted in for the variables. So S pi is equal to whatever 36 times 450 is. 16200 pi. And then if you divide both sides by pi, the pi's just cancel out. So S is really 16,200. Since we're looking for S minus T, we do that. And this 15,750 is our answer. So let's recap real fast what we did from the beginning. We were asked to find S minus T. We don't know what S or T is. So we went over here and we tried to solve for T first because it seemed easier. Then when we tried to solve for the surface area, we used this formula, but we ran into an issue because we don't know what H is. So we used this formula and the SAT's reference sheet for the volume of a cylinder to figure out what H is. We found H is 16, and then we could find T pi, which is 450. From there, we calculated the scale factor by dividing the volume of B divided by A, and then taking the cube root of that, because the ratio of the volumes of two similar 3D shapes is always the scale factor cubed. And from there, we also knew that the ratio between the two similar 3D shapes is the scale factor squared, the ratios between the surface areas. So we multiplied T pi times 36, which was the scale factor squared, to find S, and we just found S minus T. In my last video, I asked everyone to send me their hardest SAT math questions that they've seen. Thank you to everyone who's already sent theirs in. If you haven't, send me your hardest questions on Instagram at risavroy._. I appreciate you and I'm rooting for you. Let's move on. The scatter plot above shows the relationship between two variables and a line of best fit for the data. Which of the following equations best represents the line of best fit? And we have four answer choices. They all look like lines. Perfect. What we can do is we can eliminate B and C immediately. Because negative 50, right? It's not a negative slope, it's a positive slope. And if you pick D, you would be wrong. Why? You would be wrong because of this. Whenever you see this symbol on a graph, that means the scale is not to scale. This means that there's like a jump in the scale. So for example, if you go from here to here, do you see how that's 20 units? Because there's a 20 here. And do you see how this is 0.2? That's 100 times of a difference. It's a huge difference. So that means this scale is like, basically means it's not to scale. That's it. So we actually have to calculate this equation of the line. And the cool thing is that Desmos can do it for us. So pick 2 points on the line. It doesn't have to be exactly on the line, but as long as it's touching, it's going to give you at least somewhat of an accurate estimate. So the first point is going to be 20.2, 450. If you're confused on what we're doing right now, we're just calculating the line of best fit by plugging in 2 points into a table. By the way, you get the table by doing this table, right? Plus table. And then press this regression button to get the linear regression between these 2 points and export this. So this is our equation, 50x minus 560. And it's A. If you just looked at these lines and you know, just found the y-intercept just by extending the line in your head, or just like putting your finger across the screen and see like where it ends up, that's not the right way to do it. We have to actually calculate it by putting it into Desmos. Desmos can calculate it for us. Just make sure you don't get lazy here, because I've seen a lot of very smart students mess this up. triangles ABC and PQR are similar and have the following properties. Angle A is the smallest angle and angle C is the largest. The measure of angle P is equal to K times the measure of angle A. And the measure of angle Q is equal to K times the measure of angle B. The perimeter of triangle PQR is 2 times the perimeter of triangle ABC. K is greater than 1 and PQ is equal to 54. Which of the following must be true? Your first instinct should be to draw it out. And since these are similar triangles, I'm going to do my best to duplicate this. There we go. Okay. A is the smallest angle. So I'm going to label it as S. C is the largest, L. And then I'm going to label B as M for medium. Okay. Seems like at this point we have labeled everything that we can label. So now we get to the solution. Before we go through these answer choices, you should have read the answer choices already, but we really just need to figure out some more information before we, have evidence for any 4 of these, like any one of these. What I would try to figure out is what's going on with the angles in PQR. Here's what we know. These 2 triangles are similar. Now, I need you to memorize this. Similar triangles have proportional sides and congruent angles. Congruent means the exact same. So if you need to remember this by saying similar triangles have proportional sides and the same angles, then do that. Congruent shapes have the same sides and the same angles. So don't get those 2 mixed up. They're completely different. Now, one more time, similar triangles, they have proportional sides. So the sides can be different. You just have to be the same ratios. But if there's an S here, there has to be an S here. That's what the same angles means. One of these sides has to be, like one of these angle measures has to be S here because these triangles are similar. So what we can do is we can actually set 3 conditions because we know one of them has to be true. Either S has to equal KS, S has to equal KM, or S has to equal angle R. Now here's the thing. K has to be something greater than 1. So let's say it's like 2, right? It has to be something greater than 1. Now any number greater than 1 multiplied by itself is not going to equal itself. You can try it with any positive number. And how do you know S has to be a positive number? Because it's an angle. It has to be positive. So this is never going to work. S can never equal KS. The second condition is going to be S is equal to KM. And this can never work as well because M is greater than S. And you can't take a number that's greater than some number and multiply it with a number greater than 1 and expect to get a smaller number. You're basically multiplying some number times a bigger number expecting to get a smaller number. It's not going to work. The only condition that can work is that S is equal to R, angle R. S has to be right here because S cannot be this or this, and it has to be one of these three because these triangles are similar and similar triangles have congruent angles. So one of these angles has to be S. Now, if you're smart, you would have realized that this is angle M and then this is angle L. So that's why these are proportional. Basically, C is proportional to Q, B is proportional to P, and A is proportional to R. From here, we can actually go through these answer choices and we actually have enough evidence to pick one. These are the types of questions that if you don't have enough evidence to pick an answer choice, then it's wrong. So you have to have some sort of evidence. If you picked A and D, you kind of just misunderstood that these are similar. Similar triangles have proportional sides and congruent angle measures, meaning they have the same angle measures. If you chose B, that's also wrong. Let's take a look at it. PQ is equal to AB. Well, AB is the side opposite to the angle with the measure L. PQ is the side that is the opposite to angle measure S. So those sides cannot be proportional because the angles opposite to these sides are actually different. If two sides are proportional, the angles opposite to them are actually going to be the same. And that's why BC has to equal 27. Because this side, PQ, which is opposite to angle measure S, is congruent to this side, BC, which is opposite to angle measure S on triangle ABC. So that means these two side lengths are going to be proportional. And how do we know that it's 2 times less? Because the perimeter of PQR, this bigger triangle, is 2 times the perimeter of this, meaning each of the sides are going to be 2 times as bigger on this bigger triangle. So this proportional side is going to be 2 times less. 54 divided by 2. BC has to equal 27. Okay. This one was a hard one. So if this really stumped you, I get it. It's hard, especially on a time test. Some of my students told me that they got that one. That's hard. Okay. If x equals the 2nth root of 4 times x to the power of n plus 21, where n is the positive integer constant, what is the value of x to the power of n? All right. What we want to do is we really just want to take both sides to the power of 2n. Why do we want to do that? Because this actually eliminates the root. Why does it eliminate the root and only leave the stuff inside? Because anytime you take, let's say it's the cube root of x, if you take this to the power of 3, this actually eliminates the root. Because the cube root of x is the same thing as x to the power 1/3. And if you take this to the third power, it actually multiplies these two powers. So it's 1/3 times 3, which cancel out, which turns into 1. If that was too complicated, my entire point is whatever is in this section of the root, like whatever the square root is, if you take it to that power, it eliminates the root completely. And it only leaves the stuff inside. All right, from here, this is the next trick, or the next place that the SAT is going to try to get you. This is not a form that's like easy to work with. And a lot of students, I've seen a lot of students do some crazy stuff here, even some tutors, like some logarithms and everything. You don't need to do any of that. Just take a variable, like a random variable like z, and set it equal to x to the power of n. And if z equals x to the power of n, then if you square both sides, z squared is equal to x to the power of n squared, right? We're just squaring both sides. Then this is equal to x to the power of 2n because the powers multiply. And what you can do, since you have x to the power of 2n here, you just multiply. I mean, you replace that with z squared. And you have x to the power n here, so you replace that with z. And I think this form, you can tell that this is a lot easier to work with. This is just a regular quadratic. And the beautiful thing is, if you just solve this entire thing, z equals -3 and 7, you're solving for z because z is equal to x to the power of n. It asks you what is the value of x to the power of n, but you're really just solving for z because that's what you set over here. And since it's looking for the positive integer, your answer is 7. Do you see how that works? The first trick is that you take everything to the power of 2n to eliminate this root. The second trick is that you take a variable and you set it equal to this cluster of variables. Because the SAT doesn't care if you're solving for x or n individually. You're solving for the cluster. So you can just take a variable and set it equal to the entire thing. In the equation above, n and k are constants. If the equation has no solutions, what cannot be the value of n plus k? All right. I actually saw this one on my test as well. So the equation has no solutions. What can we think here? Anytime you see no solutions on the SAT, anytime you see the number of solutions on the SAT, you need to remember this. It's either a discriminant question or you're setting the slopes of two lines equal to each other every single time. Let me repeat that one more time. Anytime you see the number of solutions on an SAT question, whether it's no solutions, one solution, infinitely many, two solutions, it's either a discriminant question or you're setting two slopes equal to each other. The way you know is if there are two slopes, then you're doing this. If there's even one quadratic, then you're obviously doing discriminant. You can't set the slopes equal to each other. There's no slope in a quadratic. So in this case, we have to figure out what types of functions these two are. And they both seem like lines because they both have slopes and they both have y-intercepts. So I'm basically just plugging in n equals -7. And then this turns into -14. Okay. This is a tricky part, this last part of the question. What cannot be the value of n plus k? Well, what cannot be the value is if these two lines are the same. Why? Because right now, if these two lines are parallel, they will have no solutions, which is what the question wants. Now, there is one exception to this. If these two lines are so close together, they inch closer and closer until they're exactly the same line, then they don't have no solutions anymore. They have infinitely many solutions because they're the same line, right? So if these two are the same line, they will have infinitely many solutions, breaking this no solutions rule. Since the slopes are equal to each other, we don't need to worry about that. We just need to set these two equal to each other. Because when negative 7k equals negative 14, the two lines will be the exact same. So both of the lines will be negative 7x minus 14. You can do it yourself. You can plug in k equals 2, right? It's going to be negative 7x minus 14. So basically, k cannot equal 2 because when k equals 2, the equation has infinitely many solutions, breaking this no solutions rule. N plus k cannot be negative 7 plus 2, which is negative 5, because n has to be negative 7 because there are no solutions. But n cannot be negative 2 because then they would have infinitely many solutions because the lines would be parallel, but they would be the same line. Okay. The sum of the solutions to the equation above is 34 over 3. What is the value of A? Now, in this question, unlike the last question, it never said the number of solutions. So in this case, it said no solutions here. So we don't use that discriminant, or we don't use this rule where it's either a question that we're setting slopes equal to each other or we're using discriminant. We're not doing that. But if you ever see sum of the solutions or product of the solutions, then you need to memorize these formulas. Hopefully you have the product one memorized because this one's a little easier for students to remember. But you need to have this one memorized because the SAT actually tests this more. So negative b over a is the sum of the solutions for any quadratic. And in this case, this is a quadratic, which we'll soon see. So basically, we know that before even doing this question, negative b over a is equal to 34 over 3. Because negative b over a is the formula for the sum of the solutions. 34 over 3 is what we're given. The mistake that a lot of students make here is just dividing the entire thing by w plus 5 to cancel these out. I don't want you to do that because it says solutions plural. We need two solutions. And if you divide out the w plus 5, you lose a solution. Right now, I'm just foiling everything out. And now let's subtract the w and the 5 to the other side. Okay, perfect. We still have this equation, negative b over a equals 34 over 3. What does this even mean, this negative b over a? Well, ax squared plus bx plus c is the standard form of any quadratic. This negative b over a comes from this. So this b correlates to this. A correlates to this. So for any quadratic, if you take the value in front of the x term and divide it by the value in front of the x squared term, and then put a negative on it, then you will get the sum of the solutions. That's how the formula is used. So let's figure out what the b and a terms are. The a is pretty simple. It's just 3. Now, don't get this confused with the a that we're solving for. The a here and here is very different than ax squared plus bx plus c. This is just for the parabola. This is like the standard form of a parabola. So basically, you can think of this a right here as an a that we made up. Because, that's how we represent parabolas. But this is the a that we're actually solving for. For this formula, we replace this a with a 3 because that's the coefficient in front of the squared term. What is the coefficient in front of the x term? Because we need that bx term. Well, the w's basically represent x's, so we can replace all of these with x's if it makes it easier for us. Let's find all of the x terms. Where are they? Right here. So bx in ax squared plus bx plus c, the bx would equal 14x minus 3ax, because those are the x terms. These are the only terms that have x in them. And we can divide this entire thing by x to get b equals 14 minus 3a. This is the a that we want to solve for, right? So if we plug this into here, we get negative, make sure you put the parentheses, 14 minus 3a divided by 3 is equal to this 34 over 3. And we just replace this a with an x for now. So Desmos lets us graph. So the a that we want to find, which is the a in this equation, is equal to 16. The SAT does this on purpose, that they put this variable very similar to the negative b over a, like this a, in the formula. So make sure that you're not getting confused by the different variables. If you need to, swap this out for like some variable that's different than a, like let's say z or something. So you're solving for z instead of a. And then in this equation, just replace it with z. Solve for z. Okay, a is equal to 16. I don't know if I told you this, but we are doing another scale factor question, which is this one. I know we did one earlier, but if you want more practice, here it is. The edge length in centimeters of cube A is 4/27 the edge length in centimeters of cube B. The surface area in square centimeters of cube B is k times the surface area in centimeters of cube A. What is the value of k? Let's think back. Let's dive deep into our minds and think back to earlier in this video. What did we talk about? The edge length of one shape divided by the edge length of a similar shape is equal to the scale factor. Now, the surface area of that shape divided by the surface area of its similar shape is equal to the scale factor squared. The volume scale factor cubed. This is all you need to know to master these scale factor questions. From here, let's go back to the question and let's figure out what it's asking. The edge length of cube A, so E of A, is equal sign 4/27, the edge length of cube B. Do you see how we wrote that word for word? Is just the equal sign, right? Next one, the surface area. Let's put this down here a little bit. The surface area of cube B is K times the surface area of cube A. And I think that at this point, you can see that we have a formula that's very similar to the one that we wrote over here just a couple like minutes ago. The ratio between the surface areas is equal to the scale factor squared. So K is equal to the scale factor. Now, if you already got the answer and you answered B, you would be wrong. Just letting you know. B is not the correct answer. There we go. Sorry to crush your hopes and dreams. Okay. Let's divide e to the power b to, or not e to the power b, e of b to the other side. E of a, which is the edge length of a, divided by the edge length of b is equal to 4/27. Now, if you remember, the surface area of b divided by the surface area of a is equal to k. What's the problem here? Why can't we just take the scale factor, because 4/27 is the scale factor, and just square it? Because it's the wrong scale factor. It's the scale factor of a to b when we want the scale factor of b to a. So the reference matters, or which shape is in the numerator. In this case, the shape that's in the numerator is the b. So we want the b in the numerator here. Anytime you have a fraction over a fraction, like m over n equals a over b, you can just flip them. N over m equals b over a. Make sure there's nothing like added or subtracted to either side, but as long as it's a fraction equals to another fraction, you can flip them. And then these two get flipped, 27/4. So our correct scale factor is 27/4. K is equal to the scale factor squared, as we mentioned. 27 divided by 4 squared. And then use this fraction button right here because all of these answers are in fractions. 729/16. C is your correct answer because the correct scale factor is 27/4. All right, we got 2 questions left. Given that C, M, and P are integers, which of the following must be true? M is a factor of B, C is a factor of 90, C is a factor of B, P is a factor of 90. If you're really stuck here, the first thing that I would do is I would just, distribute this, right? Because what else is there to do really? Okay, so let's start foiling everything out. Cx squared minus cpx plus mx minus mp. And all of this is actually equal to 4x squared plus bx minus 90 because they're equal. The only two terms that have an x squared is this and this. That means that 4x squared has to equal cx squared. They're the only terms with an x squared. Meaning c equals 4. Because you just divide x squared to both sides. And from there, we can actually eliminate answer choice B. Because since we know what C is, 4, is 4 a factor of 90? Well, it's not. Doesn't 90 divided by 4 is not a whole number. So we can eliminate B. But that's probably the easiest one that we can eliminate. From here, what we really want to do is set these equal to each other. Why? Because MP is the only term out of these 4 that doesn't have an X in them. Like MX has an X, this one, they both have at least one X in them. MP does not. That means the only thing that it can equal is negative 90. So negative MP equals negative 90 because these two are equal to each other. If you multiply both sides by negative 1, the negatives just cancel out. You get MP equals 90. And from here, you can just see that D is your answer. Oh, let me write that a little better. There we go. MP is equal to 90 because 90 divided by P is equal to an integer. It's equal to a whole number. M, because it says M is an integer, meaning that P is a factor of 90. Basically, if you don't have evidence for your answer, it's wrong. Last question, you ready? The results of 2 random samples of votes for a proposition are given in the table. The samples were selected from the same population, and the margins of error were calculated using the same method. Which of the following is the most appropriate reason that the margin of error for sample A is greater than the margin of error for sample B? And it gives percent in favor, margin of error, and then these 4 answer choices. This question is way more simple than you think. All you need to know is that if any SAT question ever asks you about margin of error and sample size, you need to know one thing and one thing only. The greater the margin of error, the lower the sample size. That's it. Meaning, if the question asks, why is the margin of error of sample A greater than the margin of error of sample B? It's because the sample size is smaller. Because it's inversely correlated. That's all you have to know. In my last video, I asked everyone to send me their hardest SAT math questions that they've seen. Thank you to everyone who's already sent theirs in. If you haven't, send me your hardest questions on Instagram at risavroy._. I appreciate you and I'm rooting for you.